Good morning, class. So at this point we're looking at quadratic equations and inequalities. In today's lesson we will be looking at solving quadratic equations with fractions by factorization. Okay. The sum is normally worth between 5 and 7 marks in the exam. Okay. Depending how big the sum is and what needs to be done in the sum. So we're looking at example 1, and this is on page 34. And this is for the quadratic equations exercise 2.9 on page 36. Okay. So the question says solve for x, where x plus 1 over x plus 3 equals 2 over x plus 4 plus 2 over x plus 4 into x plus 3. So if we look at the denominator, what's the first thing we need to do is we need to factorize the denominators if possible. So make a note there. The first thing is you need to factorize the denominators if possible. Okay. Is our denominators factorized? Okay. Secondly, when you look for the LCM, so in this case the denominators are factorized. Secondly, when you look for the LCM, okay. So what is my LCM here? Okay, I meant to have taken this out, but it's here now. But anyway, so it's normally, so the LCM basically is going to be x plus 3 and x plus 4. So it's that one and this one. But if you look at that denominator, I've accounted for everything in that denominator already. Not so? So, with that comes a restriction. Now my restriction is values for which x can never be equal to. Here, they say by dividing, division by 0 is undefined. Okay? Therefore, no denominator be equal to 0. Therefore, x plus 3 can never be equal to 0, so x can never be equal to minus 3, as well as x plus 4 can never be equal to 0, therefore x can never be equal to minus 4. Does it make sense, people? So if x is 3, minus 3 or 4, negative 4, sorry, the sum will come to be undefined. When is something undefined? It's when the denominator is equal to 0. When something non-real is when under the root is a negative sign. Okay, we imaginary roots then. So, looking at that, taking that into account, we know that x plus 3 must be multiplied by what to get us x plus 3, x plus 4. What must x plus 3 must be multiplied by? X plus 4. X plus 4. So the numerator must also be multiplied by x plus 4 to get equivalent fractions. So it's x plus 1 times x plus 4. Equals. What must x plus 4 be multiplied by to get a denominator of that LCM in, which is x plus 3 into x plus 4? X plus 3. So the denominator is multiplied by x plus 3 and so on the numerator. So it's 2 into x plus 3 plus 2. So what must x plus 4 into x plus 3 be multiplied by to get this LCM? 1. So it's going to be 2 times 1. The numerator and the denominator is multiplied by the same. You get the equivalent fractions there. So what we do now? We get rid of the brackets by multiplying up. Okay? So x times x is x squared. X times 4 is 4x. X times 1 is x. 1 times 4 is 4. 2 times x is 2x. 2 times 3 is 6 plus 2. So what do I do now? Everything to one side of the equal sign. Why? Because it's quadratic. Okay, so it's going to become x squared plus 4x plus x plus 4 minus 2x minus 6 minus 2 is equal to 0. So I've got x squared, 4x plus x is 5x minus 2x. It's going to give you 3x. So 4 minus 6 is negative 2 minus 2 is negative 4 equals 0. So what do we do now? Factorize. Not so. So we now say that x plus and x minus are 4 and 1. The bigger product must be positive and that has to be negative. So x plus 4 is equal to 0, so x is equal to negative 4, or x is equal to 1. So what we do now is we check, okay, is any of those solutions a solution or a restriction there? Yes. So that means to say x can never be equal to negative 4. So you just put a line there to indicate that it can't be equal to negative 4. Okay. Any confusion there, people? No. You want to write this down? Consider pause the video at this point. Okay. So let's look at the next one. Pull this down. In example 2, and example 2 is on page 35. Example 2 is on page 35. Okay. So just coming back here, so the first step is to find LCM. First step is to factorize denominator, then to find an LCM, right? Then simplify. The third step is to simplify. Then we factorize. Okay, and then we solve for x. With solving for x, we have to check if one of the solutions overlaps the restriction. Okay. You guys got it repeated? No. Okay. Let's carry on. So, what's the first thing we need to do here? Factorize the denominator. Prepare the denominators in order to find the LCM. So what needs to be factorized here? X squared minus x minus 6. And that we can swap around. If I swap that around, what's going to happen to the sign? It will change. Okay, because as we swap it around, a negative comes out. You all understand? Okay. So what I do is, I then say it's going to be x minus 2 over x plus 2 plus x minus 8 over x minus 3 x plus 2. Okay, equals x plus 1 over x plus 2 minus x minus 2 over x minus 3. What's my LCM here? X minus 3. So we are going to write LCM x minus 3 x plus 2. So yes, I've accounted for all the denominators there. Not so. What's my restriction? The values for which x can never be equal to. My restriction says that x can never be equal to 3 and x can never be equal to negative 2. So what must this first fraction be multiplied by? X plus 2 must be multiplied by x minus 3. So it's x minus 2 times x minus 3 plus. What must this denominator be multiplied by? 1. So it's x minus 8 times 1 equals. What must x plus 2 be multiplied by to get this LCM of x minus 3 into x plus 2? So it's x plus 1 into x minus 3 minus. What must x minus 3 be multiplied by? X plus 2. So it's going to be into x minus 2, x plus 2. So what's the next thing I need to do? Simplify, get rid of the brackets. So let's multiply in here. So x times x is x squared. X times minus 3 is negative 3x. Negative 2 times x, negative 2x, which gives you negative 5x. Negative 2 times negative 3 is positive 6. Plus, get rid of that bracket, it gives you x minus 8 equals, again multiply this binomial by binomial. So x times x is x squared. X times negative 3, negative 3x. 1 times x is x, which gives you negative 2x. 1 multiplied by negative 3, negative 3 minus open brackets. Why am I keeping a bracket there? Because of that negative that must still be multiplied into that bracket. You guys understand? Right? Make sure I'm not behind the calculator there. So here it's a conjugate pair, so I multiply the first and the last. X times x is x squared. Negative 2 times 2 is. You all agree with that? The next step is I must multiply this negative in here. Not so. So I rewrite everything. I'm not going to rewrite now. But that is simply going to give us negative x squared plus. Okay. So what do I do now? Like terms. So what is x squared minus x squared? 0. So that cancels. And I bring that over, it becomes x squared. You all okay with that? What is negative 5x plus x? Negative 4x. Negative 4x plus 2x. Negative 2x. You all okay with that, people? Alright. Then what is 6 minus 8? Negative 2. Now you bring that negative 3 over, becomes positive 3. So negative 2 plus 3. 1 and 1 plus 4. 5. Okay, I made a mistake somewhere. Where's my mistake? 1 minus 4. So it's 6 minus 8. No, that's supposed to have been, yes, right, positive. So 6 minus 8 is negative 2. Negative 2 minus 3, plus 3. It's 1. 1 minus 4. Negative 3. Okay. It's easy to make a mistake here, no? So we're working with a lot of terms. Otherwise, it would have been easier to bring everything to one side first, sorted out the signs, and then added like terms there. So what are my factors? X and x, 3 and 1. Do I add or subtract my products? You subtract it. The bigger one must be negative. It's plus and minus. So what are my solutions? X is equal to 3 or x equal to negative 1. By looking at the restriction again, from the restriction what we know? X cannot be equal to 3. Let's just put a line there. Okay. So you guys understand? So with that you should be able to do exercise 2.9. Please do the odd numbers. I will check your books now. If you want the full lesson, you'll find it in the description box below.